Welcome to the beginning of Chapter 6. Chapter 6 is titled Additional Topics in Trigonometry, and which really means we've been studying trig for a long time, ever since we started the unit circle, and this is kind of going to explore a few of the broader topics that we haven't quite covered yet. And the first two being the law of sines and the law of cosines, so this video is going to work just on the law of sines. But first we need a little background knowledge. The law of sines and the law of cosines applies to oblique triangles, and if you've never heard that term before, it's just triangles that don't have a right angle in them. That would include acute triangles, obtuse triangles, you can have scalene oblique triangles, you could have isosceles, even an equilateral triangle is oblique because it doesn't have a right triangle. It doesn't have a right angle in it, I mean. And the part of these next two sections that we're going to be working on is it's really going to be finding all of the side measures and all of the angle measures to any triangle. And as long as we know one side and two other parts of the triangle, so that would mean whether we have one side and two more sides, so three sides, or one side and two angles, or two sides and an angle, we will, by the end of the next two sections, be able to figure out all parts of the triangle. And I assume that you've seen this notation before, an angle, angle, side, an angle, side, angle, or a side, side, angle. If we have any of these three given to us about a triangle, we will be able to use the law of sines. We will be looking at that today. And what we will be looking at in the future is the law of cosines. That's going to be if we have SSS or SAS, but that's going to be for another day. So, before we get into some notation for our triangles, for our oblique triangles. Most of the time, we label the 3 points. Those are going to be uppercase letters. The three vertices of your triangle, all uppercase letters. All right. So A, B, and C are the most common ones. Again, you could use X, Y, and Z if you wanted. The important part is the side that is opposite A will be called little a. The side opposite C will be little c. The side opposite B will be little b. That is going to be true for all triangles. If you call them X, Y, and Z, then opposite X would be little x. Opposite Y would be little y. All right, so the way we name our triangles is going to be extremely important. All right, you notice the same way, even though this is an obtuse triangle, it's named the same exact way. Now, for the actual law of sines, it's three equations, and you can pick any two of these three and make a proportion, because these are just fractions. This is one number A over one number sine of A, or B over sine of B, or C over sine of C. And because these are essentially all proportions, you could flip the entire fraction. If one looks easier to you than the other, go ahead and use it. It's not going to make a whole lot of difference. We will be using this on the very next slide. All right, given two angles and one side. So here, I have given us two angles. That's angle C and angle B, and this is side B. So I'm just going to write these in. This I know is 102.3 degrees. I know B is 28.7 degrees, and I know that side B is 27.4, and I don't have the units on here. But I want to essentially know, I want to figure out what is big A, and little c. I want to figure out those three portions. Now, let's start by finding little c first. And this is where we use the law of sines. If you recall from the last slide, sine of B over B is equal to sine of C over C. And if I plug into this formula, it would read sine of B, sine of 28.7 over 27.4 is equal to sine of 102.3, and I don't know this C value right here, so I'm going to call it C. And if I solve this proportion, and the easiest way to solve law of sines is cross multiply. All right, so here's a cross multiplication, and the rest is going to be really on a calculator. 27.4 times the sine of 102.3 equals the sine of 28.7 times C. So I've got out my graphing calculator here, and what I'm going to do is, it's essentially a bunch of, it's a calculation at this point. I do want to check my mode, make sure that I am in degrees, because all of my measurements are in degrees. So that's the first thing. And now it's the sine of 102.3, enter. I would need to multiply that by 27.4, enter. When I'm finally finished, I need to get c by itself. To get c by itself, I'm going to need to divide by the sine of 28.7, divide by the sine of 28.7. And at this point, you should be able to get that c is equal to, let's see here, divide by the sine of 28.7, hit enter, 55.75. So we will label that in right here, 55.75. Let's see here. Now, for angle A is actually, we could have found that first. The reason I say it would have been easy to find angle A is because I have two angles of a triangle. And if I have two angles of a triangle, then all I have to do is, I know they add up to 180. So 180 minus 102.3 minus 28.7. Enter. You would get that that is, angle A is 49 degrees even. There's really no law of sines necessary. That's just using the fact that all three angles in a triangle add up to 180. To get my last side here, angle A, well, it's another law of sines. And you would set up sine of 49 over A equals, and at this point, it doesn't matter if you use the B's or the C's. So let's use the sine of 28.7 over 27.4. I'm using the B's. You'd be more than welcome to get the C's. From here, it's cross multiply, which I hope you can do. I think this is a good place to check your work. See if you can get an answer by yourself. And if you do this correctly, you should get that little a is equal to 43.06. So why don't you try that? Make sure you can do one on your own. And I will give you one quick check when you're doing these law of sines and law of cosines. What you did learn in geometry is that if this is your biggest angle, this should be your biggest side. They should be opposite each other. If this is your smallest angle, your smallest side should be opposite it. So that's not a guarantee, but at least it means you're in the right direction. All right, so here we have a word problem, essentially very, very similar. It's going to be using a slightly different organization of the triangle, but let's see if we can come up with a picture here. It says a pole tilts, that should be tilts, toward the sun at an 8-degree angle from vertical. It casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? All right, so we have this pole that is tilting toward the sun. So here's our sun. All right, you have a pole that is tilting 8 degrees off of vertical, creating a shadow on the ground in this direction. Now we know the shadow is 22 feet long. Here's the line that's creating the shadow. And what we're looking for is we first need this angle measure, which they've given us. It's not 8 degrees, it's 8 degrees from vertical. Vertical is a perpendicular, which is 90, so we know this angle is 98 degrees. And we also know that right here we have 43 degrees. This is enough information to figure out how long is the pole, because right now you can't use law of sines, because what I have is I don't know this and its opposite. I don't know. I don't know that. I also don't know this angle, which is what I'm actually that's not the angle I'm looking for, but I don't have that angle. And I also what I need to do is I need to figure out this angle, and fortunately that's relatively easy because I have two angles in my triangle already. So you go to your calculator, you can take your 180, you minus 98, and you minus 43, and you end up, that is a 39-degree angle. So that's the first part. Now that I know all the angles, I can use law of sines, which is going to say sine of 39 degrees over 22 is equal to the sine of 43 over, and this time I called it x. From here it's cross multiply. So 22 times sine of 43 equals sine of 39 times x, and we solve for x all on the calculator. I could, if I want to save a little time, 22 times the sine of 43, hit enter, divide that by sine of 39, and I have a final answer, I know that that pole is 23.84 feet tall. 23.84 feet tall. So, what this is right here, these two problems are the basic applications of your law of sines. If you noticed in the last one, in both of these cases we were given ASA, I believe. Here we had AAS, and we had ASA, but essentially both of those were two angles. What we are going to cover is the SSA case. We are going to cover this in class. It's by far the hardest part of this section, so I'd like to discuss it in class with you. But there is one formula in the future that we will see going forward, and it doesn't involve law of sines at all. It involves the area of an oblique triangle. So you do know area of a triangle is 1/2 base times height. All right. But what we're going to prove, when we look at the ambiguous case, we are going to see that h is equal to b sine a. That's the height of a triangle, can always be written as b sine a. So what we have here is another formula that instead of using height here, all right, I can use b times the sine of a instead, the sine of a. So I can use these two pieces right here instead to calculate the area of a triangle. So if you're realizing, this c is still the base, right? So it's tricky because there's two b's in this problem. This b is standing for base, all right? But here, this b right here is talking about this b. So that's tricky because one of these b's is standing for base. That's what you're used to in your triangle formula. And you have this b right here, which is standing for the side of a triangle. This c also standing for the base of a triangle. So essentially what we have here is a formula for area, which can be read as 1/2 b sine a. I'm sorry, bc sine a. And because you can use different letters, depending if you know angle B or angle C in a triangle, it's essentially the other two sides times the sine of the other angle, the included angle, 1/2 of that. So we'll do a little practice on the next slide, and we should be able to call it a day. Find the area of a triangle that has sides 90 meters and 52 meters with an included angle of 102 degrees. All right, included angle, if you haven't heard that term before, I just mentioned it. If this is the 102 degree angle, this is the 102 degree angle right here. To be included, it's saying this side must be 90. I'm sorry, yeah, 90, not degrees though, just 90 meters. And it's saying this side must be 52 meters. So when you have this information, it doesn't matter how you calculate the area is equal to 1/2 the two sides times the sine of the included angle. All right, and that's all done on a calculator. I could do 0.5 times 90 times 52 times the sine of 102, and after that, you would say the area of this triangle would be 2,288.87. The area would be 2,288.87. So definitely leave some space in your notes. We'll be talking about the ambiguous case in class, and hopefully you come prepared knowing the law of sines. I'll see you tomorrow.